This lesson has 4 parts: adding, subtracting, multiplying, and dividing of polynomials, which these two are each a polynomial. They're actually specifically trinomials, but either way they're polynomials, and all you have to do is add the similar parts or like terms. So that's not what I wanted to do. So this is a like term with this because they each have exactly the same variable, x squared and x squared. Now there's an invisible 1 in front of here. There's 1 x squared right here, and there are 3 x squareds right here. So we're adding them together, you can see. So that's going to be 4x squares. That's a positive 2x and a negative 5x. When we add those together, we get negative 3x. Move on to these. Negative 6 plus negative 7 is negative 13. So that's one way to do adding polynomials. Let me show you another way. So here are those same two polynomials. You might prefer it like this, and then this is like the ones place, this is the tens place, this is the hundreds place, essentially like it was when you're adding integers. And so all you have to do is combine each one of these. So this would be negative 13. This would be negative 3x, and over here we have 4x squared. And here's your answer. So that's another way to do it. So let's say I was subtracting these same two trinomials, except the only difference is now I want to subtract all of these from this one. And so what I need to do is either go individually x squared minus 3x squared and get a negative 2x squared, 2x minus negative 5x gives me a 7, because this turns into a plus. Negative 6 minus negative 7 gives me a positive 1. So that's one way to do it. The other way to do it is if you literally run your negative sign all the way through here. And so this one would change into a positive, and this one would change into a positive. And then you just treat it like you're adding after that. And some people prefer that. And here are two examples when you're multiplying polynomials. Here's a very simple example that you probably already know what to do. You'll distribute property right here. So 2x and positive 6. So that's not so bad. You just apply those same principles over here, except now I'm going to distribute this one and distribute this one. So distributing the x, I get x times x squared is x cubed. X times positive 3x is, and this one is 3x squared, and the last one is 6x. Now you can keep going down this line, or when you do the next distribution, which is the 2, distribute the 2, you can move over a space and start writing that right here, and I'll show you why in a second. So let's distribute this, and that would be 2 times 3x, which is 6x again, and then 2 times 6, which is 12. And now when you move over a line, when you combine all your like terms, they're all already in the appropriate column for combining. So it's really easy to go ahead and combine these for your answer down here. Now, if you would have written all these in the same line, which is very common for people to do, then you have to go back and try to search for which ones are similar. And lastly, if you want to divide polynomials, so this would be a trinomial divided by a binomial, what you do is you refer back to that old long division like this. And you'd say, how many times does 6 go into 1? It doesn't. So how many times does 6 go into 10? It goes once. Okay, then I'll multiply this back down, and then I draw a line, change the sign, and subtract these two. So 10 minus 6, that's a 4, and bring my 8 here. 6 goes into 48. 6 times 8 is 48. 8 times 6 is 48. If you want to just double check, draw a line, change the sign, 0, no remainder, so there's no remainder up here. So that would be very similar to this. first goes into first. How many times does x go into x squared? Well, over here when you said how many times does 6 go into 10, you're looking for like what would you multiply 6 by to get close to 10. So here, what would you multiply x by to get close to x squared? Well, you can multiply by x and get x squared. So x goes into x squared x times. So then let's multiply this back down into this entire thing, like distributive property. X times x is x squared, x times 2 is 2x. Okay, this is very important. So you'll multiply this back down, draw the line, change the sign, combine all these and write it here. So these will always cancel if you do it right. This right here is a 5x, and I'm sorry I didn't change both of these signs. When I said draw the line and change the sign, you change this sign and this sign. It's a very common mistake. Comes up a lot. 3x minus 2x is just 1x. And then bring this down. Just like over here, you just keep bringing these last digits down. How many times does x go into x? So basically, now that you've done these 3 steps, you just start over. How many times does x go into x? It goes in 1 time. X times 1 is x. So I'll write that 1 up there. It's a positive 1. Now I will multiply this 1 back down to here. So then 1 times x is x. 1 times 2 is 2. Draw the line. Change all the signs. So it'll be this one and this one this time. And x minus x is nothing, 2 minus 2 is nothing, so there's no remainder, so that's it. So here we have one that's probably going to have a remainder, and we also notice that this is actually it's a polynomial with 4 terms, but it looks like this. We never write 0x squared in life, but if I present you with something that skips from a third power to a first power, you have to put this placeholder in here. So don't forget that in your homework. X cubed, x squared, x to the first, no x's. And the reason for that is, what if I had this? 123, is that the same as this? 1023. No, because this holds the hundreds place, or holds the x squared place. So these two numbers are different. So you don't want to just write cubed first power, no power over here. It's hard to keep track of what you're doing. So put your placeholder in there. So how many times does x go into x cubed? That goes in x squared times, because x times x squared will give me x cubed. Okay, so I'll write that up here and multiply this down. So x cubed plus 3x squared. Multiply it back down is what I just did. Distributive property. Draw the line, change all my signs. So I'm going to change this one and this one. What I'm really doing is subtracting these 2 lines, just like in regular long division. So now I have a new line, negative 3x squared, and I'll bring these guys down. Alright, so x goes into negative 3x squared, negative 3x times. So multiply this back down. Negative 3x times x is negative 3x squared. Negative 3x times 3 is negative 9x. Draw the line, change both of these signs. You'll notice every time I change my signs, this first column will go away. That will always happen if you're doing this right. So now I have 11x minus 3. Start over. How many times does x go into 11x? It goes in 11 times. That's because x times what will give me 11x? It's 11. So multiply this back down. 11 times x is 11x. 11 times 3 is 33. Draw my line. Change both of these signs. Negative 3 minus 33 is negative 36. How many times does x go into negative 36? Well, it doesn't. There's nothing you can multiply x by to get negative 36. So this is going to be our remainder. So what we're going to do is we're going to come up here and write our remainder on top of a fraction. I'll show you why. You put your remainder over this. Now, way back in like kindergarten or whenever it was you learned how to do long division, you might do something like this. Let's go 3 into 10. Say 3 goes into 1. Nope, 3 goes into 10 3 times. Multiply this back down. draw the line, change the sign. This gives me a 1, 3 doesn't go into 1, so sometimes your teacher would tell you remainder 1, and I wish they wouldn't, because nobody does that in algebra. What we're going to do is write this as a fraction instead. We're going to say this goes in 3 times, and 1 remainder 1/3 is what I have left over. 3 and 1/3, that's how many times 3 goes into 10. So over here, your remainder is -36, so you put -36 over what you're dividing by. That's it.